Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is Lesson 5-6, Maps and Scale Drawings. This is for Course 2, 4th period. Our objective is to use proportions to solve problems involving scale. Okay, so first of all, a couple of vocabulary words. A scale drawing is an enlarged or reduced drawing of an object that is similar to the actual object. Okay, so this could be a map, it could be a scale drawing of a building, so a blueprint or a floor plan. It could also be an enlargement, say like in science, you do an enlarged copy of a cell. Cells are very small, but when you want to label parts of a cell, you usually enlarge that. So all of those would be considered scale drawings. A scale is a ratio that compares the length in a drawing or model to the corresponding matching, right? Oh, that's an ugly I right there. Okay, length or length in the actual object. Okay, so that's very definite, always set up as the drawing to the actual, model to actual, or map to actual. Okay, just remember the real thing comes second. The drawing, model, or map comes first. Okay. All right. Now let's get into what we need to do here. It says the scale of a drawing is 1 inch equals 6 feet. So that means that 1 inch in the drawing is equal to 6 feet in actuality. The length of a wall is 4.5 inches on the drawing. Find the actual length of the wall. You can write the scale of the drawing as 1 inch over 6 feet. Then write a proportion. Let n equal the actual length. Okay, so drawing to actual. In the drawing, 1 inch represents 6 feet in real life. Let me make this a little bit larger for you. Sorry. Okay. We know that in the drawing it's 4.5 inches, so I'm going to put 4.5 up here, and I'm trying to figure out how large it is in real life. So then I'm going to write my cross products, 1 times n and 6 times 4.5. 1 times n is 1n, or just n, and 6 times 4.5 is 27. So that tells us that the actual length of the wall is 27 feet. It's that simple. If you take your scale and then take what you know, drawing on the top, actual on the bottom, what you don't know gets a variable, what you do know gets filled in, and then you solve your proportion. Okay, number 1, quick check right here. Do it now, save it for later, whichever you would prefer. All right, let's go to the next example. And this is using a map and geography, okay? So it says find the actual distance from Asheville to Raleigh. Use a centimeter ruler to find the map distance from Asheville to Raleigh. The map distance is about 4.4 centimeters, Okay, so they have a ruler here for you. They've actually measured it for you, so you know we'll all be using the same value. Use a proportion to find the actual distance. Let n equal the actual distance. Well, that's great, but I also need to know my scale. And on a map, your scale is usually written somewhere in a legend for you. Oh, I just wrote the word scale there. Okay, so it's telling us that 1 centimeter on the map represents 75 kilometers in real life. Okay, so here I go. I have my 1/75. On the map, the distance between the cities is about 4.4 centimeters. So I'm going to fill that in on top. I'm looking for the actual distance, so I don't know, so that's my n. So 1 times n and 75 times 4.4. When I simplify that, that gives me n equals 330. So the actual distance from Asheville to Raleigh is about 330 kilometers. Okay, so again, once you know your measurement and your scale, it becomes a fairly simple process of solving that proportion. Okay, here is where we are actually finding the scale. Now, when you find the scale, okay, that usually means that, let's just write a little note to ourselves. Generally, the top number is a 1 in a scale. This is not an absolute, but that's a nice little rule of thumb if you're having to find that. Okay? So, the actual length of the wheelbase of a mountain bike is 260 centimeters. The length of the wheelbase in the scale drawing is 4 centimeters. Find the scale of the drawing. Okay, so what it's telling us is the actual length and the scale length of the wheelbase. So in the picture, it's 4 centimeters. In reality, it's 260 centimeters. I want the top number to become a 1, so I'm going to divide by 4. 4 divided by 4 is 1, and 260 divided by 4 is 65. So the scale is 1 centimeter equals 65 centimeters. 1 centimeter in the picture represents 65 centimeters in real life. If you thought ahead, that means that sometimes we're actually going to have decimals in our answers. Yes, that may be the case. But anyway, basically that's how you do it though. Remember, in all of these, you're always setting up the map, the drawing, the model. Whatever you have that's not the real thing is the number that's on the top. The bottom number is always the actual item, the actual length of the item that you're dealing with. Okay, you have a couple of more quick checks for you. Actually, when you measure for number 2, I'm going to tell you that you should get about 2.1 centimeters, so that will help you then, so we'll all have comparable answers. But measure and be sure that you can get that, or see how you can get that. You don't need to measure anything for number 3. Okay, that's it. See you